All right, diving in today, resource performance solutions using Rust. We've got this really interesting article from Cubed,
Yeah, by AI alchemist Abe Orr.
right? AI alchemist Abor,
Yep.
focusing specifically on memory management in Rust. If you want to build applications that are, well, fast and efficient, this is going to be pretty key.
Yeah, and it's fascinating how Rust gives you that fine-grained control over resources. Like right from the start, the article dives into the whole stack versus heap allocation thing, which is, well, it's fundamental.
Absolutely. And the way they explain the speed advantage of stack allocation, it's crystal clear. Simple in, simple out. Cleanup is automatic. So it's blazing fast for data that's, small, fixed size, predictable lifespan. Like take the example you give. Let a RAM stack equals 0U8, 4096. Boom, 4 kilobytes right there on the stack. No fuss.
Exactly. The compiler knows exactly what it's dealing with, the size, how long it'll live, so it can handle that allocation and deallocation super efficiently. It completely sidesteps the overhead that you get with, more dynamic memory management.
Now, the article then goes on to heap allocation, which is obviously essential when you've got data that could change size, where it needs to stick around for a while. Like their example, let vector on heap, let vect on 0U8, 40096, same 4KB, but this time it's on the heap, and that gives you that flexibility. But there's a trade-off,
For
right?
sure. You're asking the system for memory every time you allocate on the heap, which takes more time. And then when you do it repeatedly, allocate and deallocate, you can end up with fragmentation, where, your available memory gets chopped up into these little pieces. And that can actually hurt performance, even if there's technically enough total memory available. So yeah, it's this constant balancing act between flexibility and speed, which is something to really think about, especially when you're building performance critical stuff.
So we've got the basics down where our data lives, but then the article takes us into memory pooling, which is like a way to optimize how you handle objects that you use a lot. Sounds pretty smart to me, cutting down on all that repeated allocation overhead.
Yeah, the whole idea is you pre-allocate a bunch of objects. So instead of going to the system every time you need one, you just grab it from your pool. The article lays it out with the memory pool struct. It's like struct memory pool objects, VIC option, AL, AAL. And they talk about the new method for creating it. Of course, you'd also need methods to, get an object from the pool and put it back when you're done. But the key is reusing existing objects is way faster than constantly asking for new memory.
Right. So if you're doing the same thing over and over, like creating and destroying similar objects, this pool is just sitting there ready to go, saving you a ton of time. And they mention needing those methods to acquire and release objects. It's like, well, almost like borrowing and returning, but within your own little managed space.
Exactly. And this is especially powerful when you're dealing with loads of short-lived objects that are all the same type. Think about like handling requests coming into a web server or, managing entities in some kind of simulation.
Makes sense. Now, next up, we've got arena allocation. The article shows the arena struct, arena storage, vect here. And then there's this allocate method, which returns a reference. It seems like a strategy for managing the lifetime of, well, like whole groups of related objects.
Right on. You basically grab this big chunk of memory, your arena, and then you carve out space for individual objects within it. And the brilliant part is you deallocate the entire arena at once. So no more tracking and freeing each individual object. You just get rid of a whole thing when you're done with everything inside.
Ah, so it's like a bulk approach to memory management. If you know you've got a bunch of objects that are going to live for about the same amount of time, you just allocate them together and then boom, free them all together when you're finished.
Yeah.
Sounds a lot more efficient than dealing with each one separately.
Yeah, it really cuts down on the deallocation overhead. And it can also improve what they call data locality, meaning related data is physically closer together in memory. And that can lead to performance gains because the CPU can access things more quickly. It's especially useful in tasks that have, distinct phases. So you create a bunch of objects, use them for a bit, and then they all become obsolete at the same time.
So looking back at what we've covered in this deep dive, it's clear that Rust gives you a lot of control over memory management, starting with, the fundamental differences between stack and heap, and then these more sophisticated techniques like memory pooling for things you use frequently, and arena allocation for managing whole groups of objects efficiently.
Yeah, and it's important to remember these aren't just abstract concepts. They can actually make a huge difference in the performance and resource efficiency of your Rust applications. Whether you're building something really demanding or just want your software to be more streamlined, understanding these memory management patterns is, well, it's crucial.
Absolutely. And it makes you think, doesn't it? When you look at all these different approaches, stack, heap, pooling, arenas, what kind of applications, what situations would really benefit from one technique over another. And it's not just about raw speed, right? It's about how complex the code becomes, how easy it is to maintain. It's a fascinating area to explore further. Thanks for joining us for this deep dive.